This is an online tutorial class where physics is brought at your doorstep. Now today we want to study physics again. Now we are going to look at the reflection of light at curved mirror. Under it today we are going to look at formation of images by curved mirror. Now recall previously that in our last class we talked about a curved or spherical mirror, where we said that we have two types of curved mirror. And what are they? We said they are the concave or converging mirror, then the convex or diverging mirror. Now we talked about the essential parts of this spherical mirror, which we mentioned and we explained them. We talked about the aperture, we talked about the pole, we talked about the center of curvature, we talked about the radius of curvature. We equally talked about the principal axis and the principal focus, where we showed in an experiment that the principal focus for a converging or concave mirror, that they have a real focus, as we saw in the practical. The images, you can get them on the screen. Then for diverging mirror or convex mirror, we found out that the principal focus, they have a virtual focus. The images, when you place them on a screen, the images, you cannot get them on the screen. Now today we are continuing with that reflection of light at curved mirror. We are looking at the formation of images by curved mirror. Remember, the curved mirror, we are talking about both the concave and the convex mirror. Now let's go over to our specific objectives. Number one, students will be able to draw a ray diagram to indicate the different positions of images formed by a curved mirror. Secondly, students will be able to solve simple problems using mirror formula and solve simple problems using mirror formula. This is an error. Then thirdly, we state some uses of curved mirror, and fourthly, you'll be able to state some applications of curved mirror, such as in parabolic mirror. Now, formation of images by curved mirrors. Now, the size or the nature and position of an image formed by a curved mirror depends on the position of the object from the pole of the mirror. Remember, we have defined all these terms. We talked about the aperture, where at the center of it you have your pole, the pole of the mirror. Now, we say that the nature of the image or the size or the position of the image you are going to form on this curved mirror, that depends on the position of the object from the pole of the mirror. Now, this can be studied by the use of an illuminated object, as we have seen in our practical. The illuminated object we used are ray box, then a concave mirror, which we have seen, and a screen. Now, firstly, when you place the object very far away from the mirror, you find out that the distance of the screen, you begin to adjust it until you have a sharp image, and the image will be found to be diminished. The image will equally be real because you can get it on the screen. The image will be inverted and it will be located between the center of curvature and the principal focus of the mirror. Now let's see this. Investigating images formed by a concave mirror. Now, as we have seen it in our practical, this is your illuminating object, that is the ray box. Now this is your screen. This is your concave mirror, and this is the mirror holder. then this is your meter rule. We have seen it practically. Now, this illuminated object, your ray burst is the object. Find out that when you place it very far away from the mirror, you can see the distance, they are very far away. What will happen? The incident ray of light from this illuminated object, when it is incident on the mirror, it will be reflected back, and you begin to see the image of this illuminated object on the screen. So you find out that when this object is very far away from the mirror, you find out that the image you're going to obtain on the screen will be what? On the screen will be diminished. So the image will be diminished. The image will equally be real. It's a real image. The image will be inverted. Now, if the object is placed at C, that is the center of curvature, the image, you find out that the image will also be located at the center of what? Curvature. Then the image will also be real. It will be the same size as the object. Now, if you place the object at principal focus, you're going to see the ray diagram of all this. You find out that you will not see any image on the screen. Why? The image is formed at what? Infinity. The image forms very far away. Very far away. The image is formed at what? Infinity. Now, if a convex mirror is used, you replace this concave mirror with a convex mirror, you are going to get a virtual image. As we saw in our practical, you cannot see the image on the screen, and the image will be erect, smaller than the object. So you can distinguish between a convex and a concave mirror by merely looking at our faces in the mirror. Now, if you look at a convex mirror, your face will look small and it will be erect. That is how you can differentiate the two mirrors, as I showed you in our practical. When you are using a convex mirror, your face looks small and it will be erect, despite the distance of the mirror to your face. When you place it very far away to your face or very close to your face, you will get the same type of what? Image. The image must be what? Erect, and the image will be small. The image will be what? Diminished. But if you use a concave mirror and look at your face, you place it very far away, a larger and an erect image of your face is seen when the face is close to the mirror. So when you place your face very close to the mirror, you will obtain a larger and an erected image. And that is why concave mirror, we use it as what? Shaving mirror. So when you place it very close to your face, you obtain an erected image. But when you place a concave mirror very far away from your face, you will obtain what? An inverted what? Image. And the image will be real. You obtain an inverted image and the image will be what? Real. Now let's look at ray diagrams of images in a concave mirror. As we have explained, let's see the ray diagrams of images formed using a concave what? Mirror. Ray diagrams of images in a concave mirror. Now, remember we have drawn a concave mirror. We say in a concave mirror, the inside surface is the reflecting part, while the outer part is the silvered part or the coated part. Now, and remember we have defined some of these terms. We talked about the pole, which is the center of the width of the aperture. We talked about the principal focus. We talked about the center of curvature and others. Now, We want to start with the first one. When object is beyond center of what? Curvature. See, what do we mean by that? When the object is placed very far away, as we have explained. Let's see the nature of the image. Remember from our explanation, we find out that the image will be small, diminished, and the image will be formed on a screen, real image. Now let's see the ray diagram. Now we look at this ray diagram. Remember a ray, you use a straight line with an arrow what? Head. Once you did not put the arrow head, you are not talking about a ray. You are just talking about a straight line. Take note. Now look at this. This is the object OX. This is your object OX. That is your illuminated object. Now this is the center of curvature. So now the object is beyond center of what? Curvature. And this is your concave mirror. Now let's see the ray of light, how they will move. The incident ray of light from this object will move straight, striking the surface of this concave mirror. It will be reflected back, passing along what? F. Take note. It will be reflected back, passing along what? F. Now, another ray of light, another incident ray from this object will move straight, striking the surface of this mirror at D. It will be reflected in a straight horizontal line. Can you see the arrow? The reflected ray. Can you see the arrow? It will be reflected in a straight horizontal line. Now, these two rays, you can equally have your third ray. Remember, we've talked about the first ray from the object. Look at it. Striking the surface of this mirror at B, we say it is reflected back. Can you see that? Now, the second ray from the object can strike this mirror at D. It is also reflected back in a straight horizontal line. So take note of the arrows. Now, where the two reflected rays meet together, that is where you have your image. Your image is formed where the two reflected rays meet together. So look at the position where the two rays meet together. That is where you have your image. Now let's describe this image. You find out that this image is what? Inverted. It is upside down. Now the image is diminished, is smaller than the object. You can see the height of this object, then you can see that of the image. The image is what? Diminished. Now the image is formed between F and what? C. You can see your F, you can see your C. Image is formed between what? F and what? C. Then another one, the image is what? Real. The image is what? Real. Meaning you can get the image on the screen. You can get the image on the screen. Now, let's see. You can see where we define the nature of the image. Number one, image is formed between F and C. We have seen it in the diagram. Look at the image between F and C. The image is real. We can get it on the screen because of the what? The intersection between the two reflected rays, where the two reflected rays meet. Then the image is inverted. You can see it here is upside down. The image is equally what? Diminished. The image is smaller than the object. Now let's see the second ray diagram. When the object is at C. Remember the first one, the object is beyond C. Now the second one, when object shift to C. Let's see the nature of image you are going to produce. Now, object at C. Look at your ray diagram here. Now look at your object OX. The object is at C. Look at your C. Look at your F. And look at your what? Your pole. Now, you are going to see the ray diagram when the object is at C. Object is at C. Now look at the first ray. The incident ray will move from the object straight, along OB. When it strikes the surface of this mirror, you can see the arrow for the incident ray. When it strikes the surface of this mirror at B, the ray will be reflected back, passing along F. Can you see it? Passing along what? F. Now, the second incident ray from the object will move straight, passing through F. When it strikes the surface of the mirror at D, it will move straight in a horizontal plane, in a horizontal direction. Can you see that? Look at the arrows for the reflected ray. One, another arrow for reflected ray. You can see that. Then for the incident ray, you can see the first arrow for the incident ray, the second arrow for the incident ray. Now, where the two reflected rays meet, that is where you have your image. Now, let's describe this image. You can see the objects at C, and the height of object is what? OS. Now, look at the height of image, also XI. Can you see that? They are of the same size. And also, the image is formed at C. Remember the first one? When you place the object far away from the center of curvature C, you have a diminished what? Image. And that is why we say when you place the concave mirror very far away from you, the image will be what? Small. Then when you bring it very close to your face, the image will be erect, and the image will be what? Higher than the object. It will be enlarged. That's the correct word. Image will be enlarged. Now, another one, the image is formed at where? At C. Now, the image is real. You can get it on a screen because of the real intersection of these two reflected rays. Then the image is equally inverted, is upside down. So you can see it. Image is formed at C. The image is real, same size as the object. Then the image is what? Inverted. And now, when object is placed at C in the concave mirror, the mirror in that case is used as a reflector behind projector lamp. Now let's see the next ray diagram. When the object is between F and what? C. Now look at it. Object placed between F and C. We are now bringing the object closer to the what? Mirror. Now objects between what? F and what? C. Now look at your objects placed between F and C. The first incident ray from the object will strike the surface of this mirror. It will be reflected back, passing through F. Now the second ray from the object will move straight, incident on the mirror. Now in the same straight line, it will be reflected back, passing along what? C. Please take note. The first incident ray from the object will move straight, striking this mirror. It will be reflected, passing through where? Through F. Now the second incident ray from object will move straight. You can see the arrow move straight, striking this mirror. It will turn back the same straight line, then passing through C. Now where the two reflected rays meet, that is where you have your image. In this case, you find out that the image is formed beyond C, very far from C. The image is a real image. You can get it on the screen. The image is inverted, is upside down. Then the image is what? Magnified. Now the image is getting larger now as you're bringing it closer to your face. Now the next one, when the object is formed at F. At F. Object at F. When you place the object at F, let's see the nature of the image. Now you look at the objects OX. is placed at F. Now the first incident ray of light will move straight, striking this mirror surface at B. It will be reflected back. You can see the arrow. Now the second ray of light from this object OX will move straight. You can see it. You can see the arrow showing it is incident, striking the surface of the mirror. In that the same straight line, it will turn back. It will be reflected back, passing through where? C. Take note. It will pass through C. Now you find out that these two reflected rays, we cannot see where they meet. They will meet very far away. And that is why we say that the image is formed at infinity, very far away, and the image will be larger than the object. It will be enlarged. So let's see the nature of the image. The image is formed at infinity. The image is real. You can get it on the screen. The image is inverted. The image is magnified. And in this position of object on the mirror, we use the mirror in this case as reflector to produce parallel beam of what? Light. Now we are going to see the next one, which is the last one. That is when object is placed between F and what? P for a concave mirror. Now look at our concave mirror. You can equally draw it this way. Remember the concave mirror, the inside part remains the reflecting part, while the outer part is the what? The coated part, or the silver there part. So you can still draw it this way. Now let's see now. The object is placed between F and what? P. That is the pole. Look at your object A, B. Now remember, in drawing this ray diagram, the distance of the pole to the principal focus F must be equal to the distance CF. What do I mean? Your distance CPF must be equal to what? FC. Take note. These distances must be equal for you to get the correct nature of image while drawing the ray diagram. Now, object between the pole and F. Look at the object. The incident ray from this illuminated object will strike the surface of the mirror. It will be reflected back along what? F. Can you see that? Now the second ray of light, incident ray from the object AB, will move straight. You can see the arrow of incident striking the surface of this mirror. It will be reflected back in the same straight line, passing through C. Now when you begin to draw these two reflected rays, you find out that they are diverging. They are doing what? Diverging. They can never meet together. But when you trace these reflected rays back, they appear to meet at a particular point. You can see the point, and that is where you have this image AB. But you can see this image is not a real image. You cannot get them on the screen. So we say they are virtual worlds image. Now let's see the nature of these images formed by a concave mirror when the object is placed between P and the focus F, the principal focus F. Number one, the image is formed behind the mirror. You can see it. Whenever image is formed behind the mirror, like in your plane mirror, image is formed behind the mirror, that image is a virtual image. You can never get it on the screen. Secondly, the image is upright or erect. You can see it. As I told you that when you bring the mirror very close to your face, you are going to obtain an enlarged and erect image. And that is why we can use this mirror as our shaving mirror. The image will be upright, so you can see it. The image standing upright, not inverted. Then thirdly, the image is magnified. You can see the height of the object. You can see the height of the image. So image is what? Magnified. And fourthly, as I said, is a virtual image. You cannot get them on the screen. Now, these are the positions of the image formed by a concave mirror. So in a concave mirror, we have only one case where we obtain a virtual and an upright image. That is when the object is placed between the pole and the principal focus F. That is the only situation where you obtain an enlarged and upright image. Apart from that position, other images are real and inverted. Now let's see the image formed by a convex mirror. Now remember what we talked about concerning a convex mirror. We said that when you bring a convex mirror very closer to your face or at any distance, even very far away from your face, that you're going to obtain a diminished and an erect image. Your face appears to look small and your face will equally be upright. So that is it. Let's see this ray diagram. Now remember, for your convex mirror, the reflecting part is the outer part. That's it. The outer part of the mirror is the reflecting part, while the inside part is the coated part. So let's see, despite the position of the object, whether it is very far, look at the object, whether it's very far from the mirror or very close, you obtain the same nature of images. Now look at the incident ray of light from this object. On striking the surface of this mirror, you can see the arrow showing its incident. On striking the surface of this mirror, it will be diverged. It will be reflected back in a divergence mood. And you can see that the reflected image diverges. Now see another ray of light, incident ray of light from the object. You can see the arrow showing its incident. On getting to the surface of this mirror, it will equally be reflected back in the same straight line. Now, if we trace these two reflected rays, they will appear to meet at a particular point. So that is why we say that the image is virtual. They appear to meet at a particular point because of apparent intersection of the reflected rays. The intersection of the reflected rays are not real. And another one, you have erect or upright image. You can see the image is erect, the image is equally upright. So number one, the nature of the image is formed behind the mirror. Image is formed behind the mirror, that is at the back of the mirror. The image is virtual. The image is erect or upright, and the image is equally diminished. Now this is the case for all positions of the object in front of the mirror. So by now you'll be able to draw ray diagrams for concave mirror at different positions of the object and that of the convex mirror. Now we're going to see mirror equation. We'll take one example. In our next class we continue. Now we look at mirror equation, or you call it mirror formula. Now the object distance u, as I've told you, if you are talking about the object distance and the image distance v, let's see, as I've said before, from this our experiments, the object distance u is the distance from the object to the mirror, to the screen. The distance of the object to the screen, that gives you the object distance, while the distance of the mirror to the screen, you can see your meter rule for that measurement. Gives you the image what? Distance. So these distances gives you the object distance and the image what? Distance. Now we are still talking about our mirror what? Equation. Now in mirror equation, these three terms are related using the formula. That is, what are the three terms? The object distance, image distance, and the focal length f of a spherical mirror. They are related using the equation 1 over u plus 1 over v is equals to 1 over f. Let's say it again. 1 over u plus 1 over v is equals to 1 over what? F. Where u is talking about the object distance, v image distance, f is talking about your focal length. And remember we said that this focal length f, the focal length f is equal to what? R over 2. As we have seen in our last class, the focal length f is equal to R over 2. That is half of radius of what? Curvature. Now when we plot a graph of 1 over u against 1 over v, you find out that the intercept on either axis is equal to 1 over f. That is, the reciprocal of this intercept gives the value of the focal length of the mirror. Now let's see how the graph looks like. So here you can see the graph of 1 over v against 1 over u. Now where the two line intersect, this one will intersect here, the other one will intersect at this point. So this point of intersection gives you 1 over f, and the other one, it equally gives you what? 1 over f. Now we are going to take one example. In our next class, we continue with the examples. Now let's take the first example, example 1. But before example 1, we have what we call the linear magnification. We represent it with m. Now for curved mirrors, the linear magnification m is produced, given by m is equals to v over u. Remember, v is your image distance and u is your object distance. And this magnification is equal to height of image all over the height of what? Object. That is image height all over the object height. Image height over the object height. Now before we solve, let's see sign convention. There is what we call sign convention that will help us to apply while solving questions under mirror what? Using mirror equation. Now this sign convention, we say that when the mirror formula is used in solving practical problems, it is necessary to add positive or what? Negative. It is necessary you add these signs of positive or negative to each of the distance according to a sign rule or convention. So according to the sign rule, the question determines whether you add positive or whether you add what? Negative. Now what is this sign convention? Number 1, you have the sign convention we call real is positive. You have another one we call new Cartesian. While solving, you can apply any of them. You can decide to be using real is positive. You can decide to use a new Cartesian. Now number 1, for real is positive, it says that real objects and real images are considered to be at a positive distance from the object. So in this case now, whenever the object and the images are real, they are always at a positive distance, that is plus. Now for new Cartesian, it says that the distance is measured to the right of the mirror are what? Positive. Now the distance measured to the right of the mirror are what? Positive. Now for number 2, For your sign convention, real is positive. We have that virtual images are at a negative distance from the word mirror. So here, whenever you have a virtual image, as we saw in our ray diagram, they are always at the negative distance. They are always at the back of the mirror. Now, under new quotation, distance is measured to the left of the mirror are what? Negative. So they are really talking about the same thing. Now, the next one, the focal length of a concave mirror is what? Positive. Now, for a concave mirror, the focal length is what? Positive. Why? Because it forms a real focus. You can obtain that image on a screen. But for your new quotation, it says that focal length of a convex, the focal length of a convex or concave mirror is what? Negative. Then finally, the third one, for real is positive, focal length of a convex mirror is what? The focal length of a convex mirror is negative. So for a convex mirror, the focal length is what? Negative, because it does not have a real focus. You cannot get it on a screen for convex. Now, focal length of a convex or concave mirror here will be what? Positive. Now, let's take one example and continue in our next class. Now, example 1. An object is placed 10 cm in front of a concave mirror. Take note, we are discussing what type of mirror here. Concave mirror. Whose radius of curvature 12 cm. Whose radius of curvature is 12 cm. What is A, image distance, B, magnification, C, the nature of the images. Now let's see. We want to use real is positive convention sign. Now remember, we were given what and what? We are giving radius of curvature to be what? 12. Now for us to get the focal length, we say that F is equals to what? R over 2. Please, this is 2. R over 2. That is plus 12 over 2. And that will give us plus 6 centimeter. It will give us plus 6 what? Centimeter. Then our U, the object, is equals to 10 cm, because the object is placed on a concave mirror. So it has, the object is a real one. We place positive there. Now we're going to use the mirror equation that states that 1 over U plus 1 over V will give me 1 over F. Now we are looking for what? Image distance. That's number A. So image distance, you're looking for V. Then we are going to make V the subject. 1 over V will be equals to what? 1 over F minus 1 over U. 1 over F minus 1 over U. Now we substitute. 1 over F is 1 over 6 minus 1 over 10. Now we use LCM. The LCM of 6 and 10 is what? 30. Now 6 into 30 will give us 5. And 5 times 1 will give us 5. Minus 10 into 30 will give us 3. Then 3 times 1, 3. So we have 5 minus 3 over 20. And 5 minus 3 will give us 20. 5 minus 3 over 30. Now 5 minus 3 will give me 20. Then all over what? 30. Then you can divide. 2 divide itself will give you 1. 2 divide 20 will give you what? 15. Now for us to get our V, we are going to turn it upside down. Remember, what we have solved is 1 over V. So for you to get your V, you use 1 to divide whatever you got as the answer. Or V will be equals to plus 15 cm. That is where image distance, where we have the image what? Distance. So the distance of the image to the screen is how many? 15 centimeter. Now we have found the image distance. Another one say the magnification and the nature of the image. Now remember we say magnification is equals to V over U. Now we substitute for our V. V is how many? From what we have solved, our V, which is the image distance, we got it to be 15. And from the question, we were given object distance U to be what? 10. Now you find out that when you say 15 over 10, we give you 1.5. So you find out that in this case, image is what? Enlarged. If the magnification is 1, that means the image size is equal or equivalent to the object size. They will be of the same size. Now you can see where we use the new Cartesian convention to solve this problem. So here your F become minus 12 over 6 over 2. That will give you minus 6. Then you have minus 10 for your U. Yeah, you substitute, you get your answer to be minus 1.5. Then after number C, the next question there says what is a image distance, B magnification, C nature of the word image. So we have seen the magnification, we want to see the nature of the image. Now number C, the image formed is what? Real. The image is magnified 1.5 and inverted. The image is what? Real, magnified and what? Inverted. Thus we obtain the same result whatever the convention we use, despite the convention sign you use, whether new Cartesian or the other one, you will get the same answer. That is, whether you're using real is positive or you're using new Cartesian, you will get the same answer. Now in our next class we are going to see other examples and we equally see the application of this curved mirror. Now my dear students, you go back and learn how to draw these ray diagrams. Very, very important. You don't need to cram them. Just learn it, know where the object is meant to be placed and know where the image will be formed. Now thank you once again for your patient listening. I remain your physics tutor, Mrs. Okuma I. See you in our next class.